Okay, now let's cover the basics of physics. So when you deal with the basics of physics, at least when I learned the physics the first time, what they introduced was a bit quite confusing me, and to clarify that kind of thing, I'll just simply introduce the one thing before. First, when I was in college walking around the campus, I saw a funny t-shirt a couple of guys were wearing, and they said something like this: biology is a science of love, chemistry is a science of lust, and the physics is, guess what? Science of sex, they said. Well, I was scratching my head a little bit. It was sort of obvious, not exactly, but then I realized when you talk about the biology in general, we say it begets new life. So, you need the love for that. So I guess that's why that makes sense. And the chemistry, when you say two people have a chemistry running with each other or something like that, then it's a sort of a lust, yeah? And the physics in normal sense, quite often think of it as somebody billiard ball or tennis ball or soccer kicking and flying and all this mechanical stuff. Purely mechanical stuff, in that sense, the physics is more like a mechanical sex kind of thing, yeah? But, so there was that, and if you talk about the physics in general, physics is divided into two different separate realms, and the one is classical physics, historically speaking, and the other one is more or less modern physics, yeah? Classical physics run all the way to the 19th century. Modern physics, give and take, beginning of the 20th century, and it goes on. And what you learn typically in the most of the high school and up to the college first year or so, I would say at least 90% of them are, 95% of them are classical physics. So that is that. Modern physics consists, there are other elements as well, roughly two. One is relativity, consisting of special and general relativity, and which started, official version is 1905 with Einstein, but actually it's more like 1900 with other pioneers like Poincaré and Lorentz and so on. Anyway, relativity started with the 20th century, and the other one is quantum physics. And quantum mechanics is basically started with at the beginning of the 20th century as well. And if you are talking about general relativity and quantum mechanics, the world is getting a little bit more spooky and not as a trivial, not simply mechanical. It's almost like a ghost inside the machine, all of the universe operating, something like that. It's much more exciting conceptually and philosophically speaking, but it's too much for at this level. So I'm just giving you the what kind of things going on behind, which confused me. So what I'm trying to say is not just simply mechanical, right? But this mechanical thing is what constitutes when you learn the physics first time, so it can be a little bit dry. It doesn't have much spirit, okay? So having said so, let's introduce the two fundamental things about the physics. One is a scalar, and the other one is called the vector. So scalar simply has a magnitude, and it doesn't care about the direction, but vector has a magnitude and also direction. Yeah, that's different. So what's the example? If you talk about this pen, this has a particular length. If you only care about the length, there is a scalar. Yes. So magnitude, we talk about the size. Only size matter. And on the other hand, if you talk about vector, this point to this direction, it's different direction, or the size can be one, but direction can be infinitely different, right? If you rotate around all of the directions. So that's the difference. So why is it important? Because if you talk about the force, if you are forcing in particular direction in physics, force this direction, the direction where you are pushing is important. If you are pushing this one, with this direction is different from this direction, right? Or equal force are pushing to the other direction, equally strong, then it's not going to go anywhere. It's going to reach the equilibrium, get stuck in the middle of it, right? So having said that, the force is, for instance, example of that. So to understand the physics properly, you really need to understand the difference between these two. So let me start from there. Okay.